right. The first thing we have to find is the SP interval. The SP interval begins with the arrival of the P wave, which is right here. It's indicated below as 0. The SP interval is the amount of time that passes between the arrival of the P wave and the arrival of the second wave, which is called the S wave. The amount of time is recorded below as seconds. So in our example, it takes 36 seconds at the top right of your page after the P wave for the S wave to hit. SP interval of 36 seconds. In order to use that to create a distance, we go down to our SP curve. The SP curve gives us a constant by which to turn seconds of the SP interval into kilometers. So in the example, 36 seconds was our example. If we follow it over to our SP curve, which is this line, and then we move directly down, we find the distance is 355 kilometers. To use this on a map, on the second page you have an activity. You have 3 different seismographs that are recordings for one particular earthquake. One is in Eureka, one is in Elko, one is in Las Vegas. You'll notice they're quite different. The first question asks you which has the most amplitude. Amplitude is measured on the y-axis in millimeters of divergence from the 0 mark. So which of these has the greatest divergence from the S or from the 0 point in the S wave, which is the second wave? The one in Eureka, the one in Elko, or the one in Las Vegas, Nevada. You'll put the answer there. Then asks you to estimate which of these, based solely on amplitude, do you think is closest to the earthquake epicenter. Think about waves and energy. Would there be more wave near the epicenter or further away? Next, we need to convert our seismographs into seconds and then convert it into distance. First, we look for the SP interval for each of these. The way we do this is, once again, we go to the point where the P wave hits, which is always marked at 0, and then we find the amount of seconds it takes before the S wave hits, which is the second wave, or the shear wave. That's the SP interval. In the case of Eureka, California, if I take my ruler and I slide it along until I see the beginnings of the S wave, I can mark it, and I see that it's 50 seconds of SP interval. Then I go back one page to the graph on the bottom. I go 50 seconds over to my SP curve, and I go down, and what I find is it's about 490 kilometers in distance. So I go back to Eureka, California, which is the first one. I register my data down here for Eureka, and I will put 50 kilometers, or 50 seconds, right there, and then I take it, and when I converted it to kilometers, I came up with 490 kilometers. So the kilometers would be 490, if you can read that. Now, the third step we need to do on this activity is to take our kilometers and to create a perimeter around Eureka, California that is 490 kilometers. We know that the earthquake was 490 kilometers away from Eureka. However, that's in a 360-degree radius, so it doesn't tell us exactly where it is. But with 3 points of data, we should be able to triangulate it. So if I take the 490, if I go to the bottom of my map, I see that I have a legend. And the bottom numbers are kilometers. So if I set my compass to 490 kilometers, like so, and then I go up to the map and I put my pin at Eureka, California, and then if I proceed to draw a circle on the map, that is going to give me all the points that are 490 kilometers away from Eureka. Now that doesn't tell me exactly where it is. I also have to do it for Elko, Nevada, and I have to do it for Las Vegas, California, or Las Vegas, Nevada. Las Vegas is here, Elko is here. And here are the seismographs that you'll use, first of all, to find the SP interval, then using your SP curve, convert it to kilometers, record your data, and then go ahead and draw the circles around those two cities, which should triangulate. Where all three circles intersect, that will be the location. When it says location from the epicenter, use the closest city and give me distance. So if it is, making this up, if it were right by Boise and it were this far from Boise, the epicenter, I take that distance down below to the legend and I see that it's 200 kilometers east of Boise. However, that's just an example. That's not where the earthquake is. You're going to need to then read through the next page, which is telling you how we determine the magnitude in Richter scale of an earthquake using what we call a nomogram, which is utilizes distance from the epicenter, which I just showed you how to do on this page, and it also uses amplitude. Amplitude, as you'll see at the top of the page, is the distance or the amount or the distance from the 0 millimeter line that the seismograph moves during an S wave. The maximum amplitude is what you want to be recording. So in this example, the max amplitude would be right here. And if we draw it to the side, it would come out exactly at 190 millimeters of amplitude. That is how we measure amplitude. We're going to do that for the three cities that you just triangulated. So we already have the distance from the three. You'll copy that from the previous page. And then using those seismograms, you'll indicate in millimeters the greatest divergent from 0 millimeters of amplitude. And then you simply go down to your nomogram and you put a mark on the distance for the particular city. And then for that same city, you then mark the amplitude, and then you'll take a ruler and you'll simply draw a line from point to point. Where it intersects the center line, that is your magnitude, and that is how you figure out your Richter magnitude of a particular earthquake.